Welcome to Study Loop.
So this question asks us what coating we have to use so that it absorbs all the radar reflection, or that no radar will be reflected from the coating. And we're asked to estimate its thickness. So this question does not give us much information. Let's say we have a plane, and then it has a coating over here. And the light will go here and reflect it. We want it to have a complete destructive interference during the reflection. So let's say this is a coating with N, and we have this. So this question does not tell us N because it says ignore any wavelengths in the coating, so we will be assuming that lambda n equals 2 centimeter. And so, but without knowing what n is, we also cannot tell what phase shift will be experienced. We know there will definitely be a phase shift here because any n will be larger than the refractive index of air, but we do not know what will happen at this surface. So because this question does not tell us that, we were just going to assume that the airplane itself will have a larger refractive index than the coating. And the reason I'm assuming that is because it asks us to ignore any change in the wavelength in the coating. So because of that, I'm assuming n is sufficiently close to the refractive index of the air. And the body of the plane is the body of the aircraft, and it will be it's, at least I would say, it's not transparent. And usually when a material is not transparent, and I would say it's probably denser, and it would definitely has a refractive index that's larger than the air. So if I'm assuming n of the coating to be close to the air, I would expect this coating, the air of the aircraft, to be larger than n. But this is really just an assumption. So in that case, I would assume if the light will experience phase shift at both of these boundaries. And in that case, if I want it to have destructive interference, then I'll have 2t equals half of lambda. So because of that, I'll have t equals 1/4 of lambda equals 2 centimeter over 4 equals 0.5 centimeter. So that would be the thickness of the coating. And if this turns out that the coating has a higher refractive index than the aircraft, then we actually have 2t equals lambda, and that would give us t equals half of lambda equals 1 centimeter. So that is if n coating is larger than in aircraft. So you can either have a centimeter of coating, or the other case is maybe you can have no coating at all, or like you can have a super thin layer of coating, because when m equals 0, it will also be a destructive interference in this case. But I think to assume the n of coating is smaller than n of aircraft is a much more realistic assumption. So for this question, I would say this is probably the answer that it's asking for. It wants us to estimate the thickness, and the thickness would be roughly 0.5 centimeter.